A vapor is a substance in the gas phase at a temperature lower than its critical point, which means that the vapor can be condensed to a liquid by increasing its pressure without reducing the temperature. For example, water has a critical temperature of 374 degrees Celsius, which is the highest temperature at which liquid water can exist. In the atmosphere at ordinary temperatures, therefore, gaseous water will condense to liquid if its partial pressure is increased sufficiently. A vapor may coexist with a liquid. When this is true, the two phases will be in equilibrium, and the gas partial pressure will equal the equilibrium vapor pressure of the liquid. Properties. Vapor refers to a gas phase at a temperature where the same substance can also exist in the liquid or solid state, below the critical temperature of the substance, which is the highest temperature at which liquid water can exist. If the vapor is in contact with a liquid or solid phase, the two phases will be in a state of equilibrium. The term gas refers to a compressible fluid phase. Fixed gases are gases for which no liquid or solid can form at the temperature of the gas, such as air at typical ambient temperatures. A liquid or solid does not have to boil to release a vapor. Vapor is responsible for the familiar processes of cloud formation and condensation. It is commonly employed to carry out the physical processes of distillation and headspace extraction from a liquid sample prior to gas chromatography. The constituent molecules of a vapor possess vibrational, rotational, and translational motion. These motions are considered in the kinetic theory of gases. Vapor pressure. The vapor pressure is the equilibrium pressure from a liquid or a solid at a specific temperature. The equilibrium vapor pressure of a liquid or solid is not affected by the amount of contact with the liquid or solid interface. The normal boiling point of a liquid is the temperature at which the vapor pressure is equal to 1 atmosphere. For two-phase systems, the vapor pressure of the individual phases are equal. In the absence of stronger interspecies attractions between like or like-unlike molecules, the vapor pressure follows Raoult's law, which states that the partial pressure of each component is the product of the vapor pressure of the pure component and its mole fraction in the mixture. The total vapor pressure is the sum of the component partial pressures. Examples. Perfumes contain chemicals that vaporize at different temperatures and at different rate in center chords known as notes. Atmospheric water vapor is found near the Earth's surface, and may condense into small liquid droplets and form meteorological phenomena such as fog, mist and HA. Mercury vapor lamps and sodium vapor lamps produce light from atoms in excited states. Measuring vapor, since it is in the gas phase, the amount of vapor present is quantified by the partial pressure of the gas. Also, vapors obey the barometric formula in a gravitational field just as conventional atmospheric gases do. Flammable liquids do not burn when ignited. It is the vapor cloud above the liquid that will burn if the vapor's concentration is between the lower flammable limit and upper flammable limit of the flammable liquid. See also, dilution, evaporation, Henry's law, vapor trail, vaporizer, references.